Is the solar constant, or does it change? Ask NASA about the solar constant, and all you'll get is a snow job about sunspots. No, boys and girls, we're not interested in short-term cycles. We want to know what causes the ice caps to grow and retreat. We want to know what really causes climate change. The answers, according to my theory, are out there. Earth's climate is the result of conditions in space, and the proof is in the ice cores and deep ocean sediments. They're called radioisotopes. But first, what is the solar constant? Imagine a solar panel measuring 1 meter by 1 meter. If you aimed this panel so that it could receive a maximum of sunlight, tilted it perpendicular to the sun's rays, it would receive 1.37 kilowatts. The Encyclopedia Britannica defines solar constant thusly: the total radiation energy received from the sun per unit time per unit of area on a theoretical surface perpendicular to the sun's rays and at Earth's mean distance from the sun. It is most accurately measured from satellites where atmospheric effects are absent. The constant is fairly constant, increasing by only 0.2% at the peak of each 11-year solar cycle. Sunspots block out the light and reduce the emissions by a few tenths of a percent, but bright spots, called phages, that are associated with solar activity are more extensive and longer lived, so their brightness compensates for the darkness of the sunspots. In other words, the sunspots hardly have any effect. Moreover, as the sun burns up its hydrogen, the solar constant increases by about 10% every billion years. I have a theory as to what would cause it to change dramatically. You can understand the principle of a Geiger counter. And suppose that this is my Geiger counter. And suppose there's radioactive paint on this can of chicken noodle soup. But I don't know where it is. When I bring the Geiger counter closer, it clicks more. And when I take it away, it clicks less. And I can actually, by the intensity of the clicking of this Geiger counter, I can determine the source of the radiation. I determine that it's coming from this area right here. It's not coming from up here, and it's not coming from over here. I can zero in on the source of the radiation by the number of clicks of the Geiger counter. This would give me more clicks. This would give me less. In a similar fashion, if you put a type of a Geiger counter in space, it will receive more clicks than that same Geiger counter on the ground.